Okay, so here is when things start to get interesting. This is where we start to have, that was a really weird inflection on the word interesting. I didn't like that. But this is where things start to get harder, is when we have to deal with more than one object in our system. So the system shown is released from rest. If friction is negligible, the acceleration of the 4 kilogram box or block sliding on the table shown is something. So we have to figure that out. So again, pause it, give it a go, see what you got, and then we'll try it out. Okay, so what we're going to do here is no different than our process before. We're going to draw our force diagrams for both of our objects. So we're going to draw, first I'm going to start off with this one, the 4 kilogram mass. Doesn't really matter. But so just like I've been doing, I'm going to circle my object, identify the contact forces, and then draw that force diagram. So I'm going to say here is this 4 kilogram mass. We know that it has this tension force from the string that is pulling on it. So we have this force of tension. It's pulling it to the right. And then if I'm thinking about what else is acting on it, I know that I have the downwards gravitational force. And then I also have an upwards force from the contact between the surface and my object. So I got that normal force that acts perpendicular from surfaces. In this case, it tells us that the table is, our friction is negligible, so we don't have any friction. That just means there's no friction acting on it. So we have this situation for our 4 kilogram block, and now we can do the same thing, but with our 2 kilogram block. So again, I'm going to circle it. That's not a good circle. So I can circle it, identify the points of contact, and really the only thing contacting it seems to be that rope. So let's come in here and say, okay, this is my 2 kilogram block. And then I can say there is a downwards force and an upwards force. My upwards force is from that contact, that tension, and then my downwards force is this gravitational force. And then one thing to note, if we're looking at this situation, we can see very visibly that our 4 kilogram block is going to be accelerating to the right. So we can maybe just draw in there just to remind us, okay, this is accelerating to the right. We have this unbalanced setup where it's very clear that this thing has an unbalanced force to the right, which means it's going to be accelerating to the right. If this block is accelerating to the right, it means our system is accelerating in that direction. The pulley just kind of changes the direction. So we know that this 2 kilogram block is going to be accelerating downwards. So I'm going to take a quick little note of that because it's going to be important. It's going to be important for us to remember that and keep that in mind when we're doing our setup. So now what I can do is do my setup for both of my blocks. I want to figure out, I want to end up knowing the acceleration of the 4 kilogram block. So what I can do is set up my equation for this 4 kilogram block and say, okay, F net equals mass times acceleration. It's accelerating the x direction, so our net force in the x direction is Ft is equal to 4 times A. So that's not great because we have two unknowns. We don't know Ft and we don't know A. So let's come over here and say, well, this tension is the same throughout the rope. We don't have differing tension throughout the rope. So if we can figure out the force of tension from looking at our second block, then we'll be in pretty good shape. We'll know this Ft, and then we can solve for this A. So because it's the same rope, it's going to have the same tension throughout, which means we can set up Newton's second law over here. We say we have tension is pointing up, force of tension minus force of gravity is pointing down, is equal to mass times acceleration. This has a 2 kilogram mass times our acceleration. And then we said, oh, this thing is accelerating downwards. It's accelerating in our negative direction. So it's going to be important for us to come in here and say, okay, this is a negative acceleration. So this is important because we're defining down as negative. So we have to make sure that we're remembering that we're calling this negative, that this is going in what we're saying is the negative direction. So that keeps everything the same throughout our system. So now what we said was we were going to solve for this force of tension equals negative 2a. We can add fg to both sides, and we can even go a step further and solve for this fg. We know that force of gravity is just m times g. Our mass was 2 for this block, and then g we can just call it 10 instead of 9.8, just to make calculations easy. So we can say our force of tension is equal to negative 2a plus 20. So not exactly what we wanted. It's a good start. We have an equation for the force of tension, but we're going to have to use it to actually solve for this acceleration. We won't be able to just directly plug in, kind of have to solve, but you know what, that's okay. So in our x direction, we said that we had this equation that said ft equals 4a. Now we have ft equals negative 2a plus 20. Both of these are equations for ft, so we can set them equal to each other. We can say the tension is equal to 4a, and the tension is equal to negative 2a plus 20. So I can solve this. I can bring all the a's together. So add 2a to both sides. And that is 10/3, which is not a nice fraction. 3 point, oh, I should have been able to do that. 3.33 meters per second squared. And then if they'd asked us for the tension, we could have just plugged a in and said, okay, it's 4 times 3.333, but they didn't ask us that. So yeah, our acceleration is 3.333 meters per second squared.